In the vast expanse of space, stars are often seen as the eternal beacons of light, shining brightly across the cosmos. But this light is not everlasting. In reality, stars go through dramatic transformations, born from clouds of gas and dust, burning intensely for billions of years before ultimately perishing in a spectacular flash. Our journey begins in one of these stellar nurseries, the Orion Nebula, a place where new stars are constantly being born and old ones are meeting their ends. The Orion Nebula, located approximately 1,344 light-years away, is a vast cloud of gas and dust, a cosmic nursery where stars form in a cauldron of activity. It is a region where the universe's raw potential is unleashed as gravity pulls the surrounding material together to create new stars. This cloud is not a silent, empty void, but a bustling, chaotic birthplace of powerful cosmic objects. The nebula is filled with massive amounts of material in constant motion, colliding and mixing under the influence of gravity. The nebula's complexity is breathtaking. Its size alone, covering more than 1,000 light-years, is enough to make it one of the most remarkable regions in the entire Milky Way. Within this vast structure, new stars are born, some of which will shine for billions of years, while others will burn out much sooner. The process of star formation within the Orion Nebula is a turbulent one, with immense forces at play. Stars are not simply created in isolation, they are part of a dynamic process that involves interactions with the surrounding gas and dust, shaping their evolution. At the center of the nebula, we find the trapezium star cluster, a collection of some of the most brilliant and massive stars in the region. These stars are incredibly young, no more than a few million years old, and yet they already shine with incredible intensity. The largest of these stars is Theta 1 Orion C, a massive white-blue star with a temperature of around 45 Kelvin. This star is so powerful that it has an immense effect on its surroundings, emitting large amounts of radiation that ionize the gas and dust around it, creating the characteristic glow of the nebula. The radiation from Theta 1 Orion C pushes the surrounding gas outward, creating a cavity in the center of the nebula where the material is being swept away, leaving behind a region of almost empty space. Despite the immense energy of these stars, the nebula is far from being a quiet place. The process of star formation is ongoing, with new stars constantly being created in the dense regions of gas and dust. One such example is the protostar Orion 294-606, which is still in its early stages of development. This young star is surrounded by a massive disk of gas and dust, a protoplanetary disk that will one day give rise to planets and moons. As Orion 294-606 continues to grow, its heat and radiation will begin to clear out the surrounding material, slowly revealing the full shape of this young star system. In the midst of this cosmic maelstrom, the forces of gravity and radiation are constantly at odds, with stars vying for dominance over the surrounding gas and dust. The nebula is in a constant state of change, with new stars being born, old ones dying, and the material around them constantly shifting and evolving. The future of the Orion Nebula is uncertain. In a few 100,000 years, the nebula may begin to dissipate, its gas and dust being consumed by the stars that are born within it. The remnants of this process will eventually give rise to new star clusters, and the cycle of star formation will continue. Yet, even in the midst of this chaos, some regions of the nebula remain relatively calm. These areas where gas is cooling and condensing are the perfect places for new stars to form. Within the nebula, there are approximately 700 protostars still in their infancy, slowly gathering mass and energy as they prepare to shine. These stars are the future of the universe, each one a potential source of light and life, waiting to be born from the swirling gas and dust that surrounds them. But not all of the nebula's energy comes from the formation of stars. There are also massive currents of gas moving at incredible speeds with velocities of up to 50 kilometers per second. These currents are created by the radiation pressure from the massive stars, and they move through the nebula, shaping and reshaping the environment. In some areas, these currents have created vast sheets of gas that stretch across light years, their structure a testament to the immense forces at work in this cosmic laboratory. As we move deeper into the nebula, we can see regions where the gas is cooler, where the process of star formation is just beginning. Here, the gas is dense, and the temperature is low enough for the material to condense into the cores of protostars. These regions are the future of the nebula, where the next generation of stars will be born. It is a place of both immense potential and incredible danger, where stars are created from the raw material of the universe itself, but also where the forces of nature are constantly at odds. The Orion Nebula is not just a place of creation, it is also a place of destruction. Some of the stars born within the nebula will burn out quickly, their cores collapsing in on themselves to form neutron stars or black holes. These violent deaths will release enormous amounts of energy, causing shock waves that ripple through the surrounding gas and dust, triggering the formation of new stars in the process. The future of the Orion Nebula is uncertain. Some scientists predict that the nebula will eventually dissipate, with its gas and dust being swept away by the radiation from the stars. Others believe that the nebula may give rise to a new generation of stars, continuing the cycle of star formation that has been ongoing for billions of years. Whatever the future holds, one thing is certain. The Orion Nebula is a place of unimaginable beauty and chaos, where the forces of gravity, radiation, and time come together to create the stars that will light the universe for generations to come. As we venture deeper into the heart of the Orion Nebula, the forces of nature begin to reveal themselves in their full intensity. The very fabric of space seems to twist and turn as massive stars continue to form and die. The nebula is not just a place of creation, but a battleground where gravity, radiation, and the remnants of ancient cosmic forces collide in a fierce and endless struggle. The stars that emerge from this chaos will go on to shape the universe itself, their stories written in the light of distant galaxies. At the core of the nebula, we are introduced to a phenomenon known as stellar winds. These are powerful bursts of energy that flow outward from the stars, carrying with them the material of the nebula itself. The winds are driven by the intense heat and radiation of the young stars, pushing the surrounding gas and dust into the vast reaches of space. These stellar winds are so powerful that they can carve out vast cavities in the nebula, creating regions where the material is stripped away, leaving behind only the glowing cores of the forming stars. But the winds don't just destroy, they also create. As they push outwards, the gas they carry with them cools and condenses, forming new stars and even planets. This process is not immediate, but over time, the winds slowly shape the environment of the nebula, pushing the gas and dust into new configurations. It's here that we see the birth of some of the most fascinating and unique structures in the universe, planetary nebulae. These are regions where dying stars shed their outer layers, creating beautiful glowing clouds of gas that shine brightly in the cosmic void. As we explore these nebulae, we are drawn to one of the most mysterious aspects of the Orion Nebula, the formation of binary and multiple star systems. In the chaotic environment of the nebula, stars often form in pairs or even groups, bound together by their shared gravity. These systems are not only beautiful, but they are also fundamental to our understanding of star formation. For years, scientists have studied binary systems to learn more about how stars evolve and interact with each other. In these systems, we can observe firsthand the gravitational dance between two stars, their fates entwined as they orbit each other, sharing mass and energy. One such system is Orion 2324 76E5, a binary pair of stars locked in an eternal orbit. The two stars are close enough that their gravitational forces influence each other significantly. In fact, their orbits are so tight that the stars actually share material with one another, creating a dynamic exchange of gas and energy. This process not only fuels the stars, but also leads to the formation of exoplanets, planets that orbit stars outside our solar system. As the material from one star is pulled into the other, it forms a disk of gas and dust that gradually condenses into planets, moons, and even asteroid belts. The study of these binary and multiple star systems is more than just a scientific pursuit. It is a key to understanding how our own solar system came into being. The process of star formation in the Orion Nebula is similar to the conditions that led to the birth of our Sun and its planets. By studying these systems, we can gain insights into the forces that shaped our own cosmic neighborhood and learn more about the delicate balance of nature that governs the evolution of stars and planets. As we move deeper into the nebula, we encounter regions where the gas and dust are denser, and the process of protostellar formation is in full swing. These are the places where new stars are born, their cores slowly heating up as they gather mass. The gravitational collapse of these regions triggers nuclear fusion at the center, and a new star is born, ready to join the ranks of the brilliant lights that fill the cosmos. The heat and energy released by these stars push the surrounding gas and dust outward, creating a beautiful glowing cloud of material that will eventually form a star system. But the birth of a star is not a simple process. It is violent, chaotic, and sometimes deadly. At the edge of the nebula, we witness the death of a star, CW Leonis, a red giant nearing the end of its life. The star, having exhausted its nuclear fuel, begins to collapse under its own gravity. As the outer layers of the star are squeezed inward, they heat up, creating an intense pressure that forces the star to expand. This process, known as stellar inflation, causes the star to grow to many times its original size, becoming a massive red giant. But this expansion is only temporary. Eventually, the star will shed its outer layers in a massive explosion, known as a supernova, leaving behind a dense hot core that will either become a white dwarf, neutron star, or in some cases, a black hole. The death of a star is not just an end, but a new beginning. The explosion of a supernova releases vast amounts of energy and material into space, seeding the surrounding nebula with the elements necessary for the formation of new stars, planets, and even life. The remnants of the dying star become part of the nebula, contributing to the creation of new cosmic structures. In this way, the death of a star is intimately connected to the birth of new celestial objects, and the cycle of life and death in the universe continues. As we approach the outer regions of the nebula, the dynamics of star formation begin to change. The material in these regions is less dense, and the stars are farther apart. But the forces at work are no less intense. In these outer regions, the formation of new stars slows down, and the remaining gas and dust is gradually consumed by the existing stars. Over time, the nebula will dissipate, its material scattered across the galaxy, leaving behind only the stars and planets that were born from it. The future of the Orion Nebula is uncertain. Some scientists predict that the nebula will eventually dissipate, its gas and dust consumed by the stars. Others believe that the nebula may continue to give birth to new stars for millions of years to come. Whatever the outcome, the Orion Nebula is a testament to the incredible forces at work in the universe. Forces that shape the cosmos and determine the fate of stars, planets, and galaxies. As we leave the Orion Nebula behind, we are reminded of the fleeting nature of life in the cosmos. Stars are born, they burn brightly, and then they fade away, only to be replaced by new stars, new planets, and new possibilities. The cycle of creation and destruction continues, driven by the immense forces of gravity, radiation, and time. And as we move forward, we are left to ponder the ultimate fate of the universe itself. What will become of the stars, the galaxies, and the black holes? Only time will tell. As we journey further into the cosmos, beyond the edges of the Orion Nebula, the universe opens up like an endless, uncharted map, filled with both wonders and dangers that stretch far beyond what we can imagine. But even as the stars are born, live, and die, one question lingers above all others. What lies beyond the nebula? What comes after the birth of a star? Leaving the nebula behind, we find ourselves at the crossroads of the universe, observing the vast stretches of space where stars are in various stages of their existence. In the cold darkness, we encounter the oldest of stars, the white dwarfs. These remnants of once mighty stars are the corpses of giants that have exhausted their fuel. They shine faintly, cooling and slowly fading away over billions of years. White dwarfs are strange, complex objects, dense enough to pack the mass of the sun into a volume no larger than Earth. Their gravity is so intense that a single teaspoon of white dwarf material weighs as much as a mountain on Earth. But what's truly remarkable about these stars is the process of their decay. As they cool, they shrink, slowly becoming dark and invisible, until, after trillions of years, they might eventually fade into the dark matter of the universe, leaving behind only their gravitational imprint. Somewhere deep in the cosmic vastness, beyond the reach of our telescopes, there are also the remnants of supernovae, stellar explosions so massive that they outshine entire galaxies for a brief moment in time. These colossal explosions mark the end of the life cycle of the most massive stars, but they also give rise to new cosmic entities, neutron stars and black holes. A neutron star, much like a white dwarf, is a remnant of a collapsed star, but it is far more extreme. These stars are incredibly dense, so much so that a single cubic centimeter of neutron star material could weigh as much as a mountain on Earth. Neutron stars are the densest objects in the universe, except for black holes, and they possess some of the most extreme properties imaginable. A neutron star's gravity is so strong that it bends the fabric of space-time around it, warping the space in a way that's almost impossible for us to comprehend. As we move closer to one of these stellar remnants, we begin to experience the effects of space-time distortion. The sheer gravity of the neutron star creates a lens-like effect, warping the space around it and bending light itself. The stars behind it appear distorted, smeared, and stretched. The closer we get, the stranger the universe looks, as if reality itself is unraveling. The bending of space-time near such an object is so intense that it becomes impossible to see what lies beyond it. It's a cosmic event horizon, the edge of the known universe, where the laws of physics themselves break down. But as we push onward, we encounter something even more sinister. Black holes. These cosmic giants, formed from the collapse of massive stars, have no equal in the universe. A black hole's gravitational pull is so intense that not even light can escape. They represent the ultimate paradox of the universe, an object that contains both the beginning and the end of everything. A black hole is a place where space and time become distorted beyond recognition. The moment you cross its threshold, you are lost forever, drawn into a region of infinite density and gravity, a place where the rules of physics cease to function. Black holes are not merely cosmic oddities, they are the architects of the universe's most mysterious forces. They act as cosmic engines, shaping the galaxies around them, driving the formation and destruction of stars, and dictating the overall structure of the cosmos. The most infamous of these black holes are the supermassive black holes found at the centers of most galaxies. These monstrous objects are millions, if not billions, of times the mass of the Sun, and their gravitational pull shapes the very nature of their host galaxies. It is now widely accepted that supermassive black holes play a crucial role in the formation and evolution of galaxies. As these black holes devour matter, they release vast amounts of energy, lighting up the surrounding space in the process. The radiation emitted from the accretion disks around these black holes is so intense that it can outshine entire galaxies, creating quasars, one of the brightest phenomena in the universe. These black holes not only dictate the growth of galaxies, but they may also be responsible for their eventual death. As black holes consume more and more matter, they influence the rate at which stars are born, determining the overall health of their galaxies. But what happens when these black holes merge? When two supermassive black holes collide, the results are nothing short of catastrophic. The collision sends gravitational waves rippling through the fabric of space-time itself, disrupting the very structure of the universe. These waves, first predicted by Albert Einstein over a century ago, were only recently detected by the LIGO observatories in 2015, confirming that black holes, when they merge, can indeed send out powerful ripples through space-time. This discovery opened up a new window into the study of black holes and allowed scientists to observe these cosmic giants in a completely new way. Yet even with these groundbreaking discoveries, the true nature of black holes remains elusive. We still don't fully understand the processes that occur within their depths, nor do we know what happens to the matter that crosses their event horizons. Some theorists suggest that black holes could act as portals to other universes, or that they might contain the key to understanding the very fabric of reality itself. Others believe that black holes are not just cosmic destroyers, but the building blocks of new universes, each one a seed from which a new cosmos could be born. As we continue to unravel the mysteries of black holes, we must ask, where does all this lead? Will we ever unlock the secrets of these enigmatic objects, or will they forever remain the universe's greatest mystery? As our understanding deepens, we are forced to confront the possibility that the universe is far stranger and more complex than we ever imagined. In the end, black holes remind us of the fragile nature of our understanding of the cosmos. They challenge us to push the boundaries of science and imagination, to look deeper into the unknown, and to confront the possibility that we may never fully comprehend the forces at play in the universe. But that doesn't stop us from trying. It's this drive, this insatiable curiosity that will continue to propel humanity forward as we search for the answers to the most profound questions of all. What are black holes? What do they mean for the future of the universe? And perhaps most importantly, what lies beyond their grasp? As we conclude this journey through the cosmic abyss, we are reminded that in the universe there is always more to discover. The story of black holes is not just about their existence, but about the limits of human knowledge and the infinite possibilities that lie beyond. The universe is vast, mysterious, and filled with wonder, and the search for understanding will continue for as long as humanity gazes up at the stars. As we delve further into the enigmatic mysteries of the universe, our journey takes us beyond the confines of what we once thought was possible. Beyond black holes, beyond the dazzling stars, lies the deep, uncharted darkness of the cosmos, a place where the very fabric of space and time begins to unravel. As we move forward, we encounter phenomena that defy even the most advanced theories in physics, opening new doors into the vast unknown. At the core of these mysteries is the concept of dark matter, an invisible substance that makes up approximately 27% of the universe. We cannot see it, touch it, or measure it directly, yet we know it exists because of its gravitational influence on visible matter. Dark matter is the unseen hand that holds galaxies together, preventing them from flying apart due to the immense gravitational forces at play. Without dark matter, galaxies would not exist in the form we see them today. In fact, its presence is fundamental to the structure and evolution of the entire cosmos. But what is dark matter made of? For years, scientists have been searching for answers, using particle accelerators, telescopes, and even underground laboratories, in hopes of catching a glimpse of this elusive substance. Despite our best efforts, dark matter remains a mystery, and many scientists have even begun to question whether it may be something beyond our current understanding of physics. Could it be that dark matter is a manifestation of some unknown force, one that exists in parallel with the familiar forces of gravity, electromagnetism, and the strong and weak nuclear forces? Could it be that dark matter is not a substance at all, but rather a manifestation of the fabric of space-time itself, distorted in ways we cannot yet comprehend? As we ponder these questions, we turn our attention to a related enigma: dark energy. Even more mysterious than dark matter, dark energy is the force that drives the accelerated expansion of the universe. It accounts for roughly 68% of the universe's total energy content, yet, like dark matter, it cannot be observed directly. All we know is that dark energy pushes galaxies apart, causing them to move away from each other at an ever-increasing rate. In fact, The expansion of the universe has been accelerating for the past 5 billion years, a discovery that has stunned scientists and forced us to rethink the very nature of the cosmos. The implications of dark energy are profound. If dark energy continues to accelerate the expansion of the universe, what will become of the galaxies, the stars, and even the black holes that populate the cosmos? Will they continue to drift farther and farther apart until the universe becomes a cold, empty void? Or is there something more at play, some force or process we have yet to discover that will alter the fate of the universe? Could dark energy itself hold the key to the ultimate fate of everything we know? As we continue our exploration, we realize that the universe is full of unanswered questions. The more we learn, the more we realize how little we actually know. One thing, however, is certain. We are not alone in the cosmos. The search for exoplanets, planets that orbit stars outside our solar system, has revealed a startling truth. There are potentially billions of planets out there, each with the possibility of supporting life. From rocky planets like Earth to gas giants, the diversity of exoplanets is staggering. Some orbit stars similar to our Sun, while others circle around red dwarfs, stars that are much smaller and cooler than our own. The discovery of exoplanets has opened up new avenues for understanding the potential for life beyond Earth. Planets in the habitable zone, the region around a star where conditions are just right for liquid water to exist, are of particular interest. In recent years, telescopes such as Kepler and TESS have discovered thousands of exoplanets, and astronomers are now focused on identifying those that could harbor life. Some of these exoplanets are shockingly similar to Earth, with temperate climates, liquid water, and the possibility of conditions conducive to life. Yet, as we ponder the existence of life beyond our planet, we must also confront the possibility that we may never find definitive proof. The vastness of the universe is so incomprehensibly large that even if life does exist elsewhere, the distances between us and these distant civilizations may be insurmountable. The light from the nearest exoplanet is measured in light years, meaning that even if we discovered a potentially habitable planet tomorrow, it would take us tens of thousands of years to reach it with current technology. But the search for life continues, driven by the profound question, are we truly alone in the universe? The discovery of even the smallest hint of life on another planet would shake the very foundation of human understanding. It would challenge everything we know about biology, evolution, and our place in the cosmos. Could it be that, as we explore the vast reaches of space, we will eventually uncover evidence of a universe teeming with life, both familiar and strange? Or will we remain isolated, left to ponder the mysteries of the cosmos alone? Meanwhile, we must also consider the ultimate fate of the universe itself. As dark energy continues to drive the accelerated expansion of the cosmos, what will become of all the galaxies, stars, and black holes that populate the universe? One theory, known as the Big Freeze, suggests that the universe will continue to expand forever, growing colder and darker as galaxies move farther and farther apart. In this scenario, stars will burn out, and galaxies will be left isolated in the vast expanse of empty space. Eventually, even the black holes may dissipate, leaving behind a cold, lifeless universe. But there is another possibility: the Big Crunch. In this scenario, the expansion of the universe could eventually slow and reverse, pulling everything back together in a massive gravitational collapse. The galaxies would collide, stars would be drawn together, and black holes would merge in a cataclysmic final event. The universe would collapse in on itself, leading to a singularity, a point of infinite density where the laws of physics break down. This could be the end of the universe as we know it, but it may also be the beginning of something new. Some theorists suggest that this singularity could give rise to a new Big Bang, a fresh beginning for the cosmos. Whether the universe continues to expand forever or collapses into a single point of singularity, we are left with the profound realization that we are just a tiny part of something far greater. The universe is a vast and incomprehensible place, filled with wonders, dangers, and mysteries beyond our understanding. The more we learn, the more questions arise, and the more we are reminded of how much we have yet to discover. As we stand on the edge of the unknown, we are filled with awe and wonder, knowing that the answers to some of the universe's greatest mysteries are out there, waiting to be discovered. The search for knowledge continues, and with each new discovery, we get one step closer to understanding the true nature of the cosmos. As our journey continues, we find ourselves at the precipice of one of the greatest questions in cosmology. What is the ultimate fate of the universe? The mysteries of dark matter, dark energy, and black holes have brought us to this moment of realization, where the very fabric of space-time itself is under threat from the forces we struggle to understand. But in the midst of this cosmic turmoil, a final pressing mystery remains. How does it all end? The story of the universe is not just one of creation, but one of inevitable decline. Whether through a slow, gradual fading into nothingness or a violent cataclysmic collapse, the universe will one day come to an end. But what does that end look like? And, perhaps even more hauntingly, what happens after? We know that the universe is expanding and at an accelerating rate, driven by the mysterious force of dark energy. But what happens when the last star dies out? What remains when the last galaxy fades into the darkness? Some theorists propose that the universe could continue expanding until it reaches a state of complete thermodynamic equilibrium, where all matter is evenly distributed and no energy or motion is left. This would be the end of all structure, the ultimate heat death of the universe. The light of stars would dim, galaxies would be scattered far apart, and the only things left would be the remnants of what once was. A cold, lifeless void where time and space lose their meaning. But the story of the universe may not end in a quiet fade. There is another theory, one more dramatic and far more terrifying: the Big Rip. In this scenario, the very fabric of space itself is torn apart by the relentless expansion of the universe. As dark energy accelerates the expansion, galaxies, stars, planets, and even atoms would be pulled apart, their bonds undone by the increasing forces. The universe would ultimately reach a point where everything is torn asunder, ending in a final violent end. The very laws of physics as we know them would cease to hold, and the universe would collapse into a singularity, a point of infinite density. Somewhere in the depths of these possibilities, we are left with the realization that no matter how the universe ends, the end is part of a cycle. The very forces that govern the birth, life, and death of stars may also hold the key to the rebirth of the universe. Some suggest that when the universe reaches its final state, it may trigger the conditions for a new Big Bang, a fresh beginning born from the ashes of the old. The universe may never truly die. Instead, it may transform, collapse, and re-emerge in a never-ending cycle of creation and destruction. Yet, even as we contemplate the end, we realize that there is still so much to explore, so much we have yet to understand. The ultimate fate of the universe may be beyond our reach, but the journey itself, the exploration of space, the search for answers, the understanding of the forces that govern us, remains the essence of human curiosity and discovery. As we continue to peer into the cosmos, we are reminded that the universe is not just something to observe, it is something to engage with, something to explore, something that challenges us to reach beyond the stars. At this very moment, our telescopes are scanning the depths of space, looking for the faintest glimmer of new knowledge. We have sent probes to the farthest reaches of the solar system, and yet we are just scratching the surface of what is out there. The James Webb Space Telescope will soon give us a clearer view of the distant past, shedding light on the first stars and galaxies that formed after the Big Bang. With each new discovery, we move closer to understanding the true nature of the cosmos. The universe is vast, and our place in it is but a fleeting moment. We are born from stardust, and we will return to it in time. But in that brief moment, we have the opportunity to explore, to discover, and to understand. The journey we are on is far from over, and though we may never fully grasp the ultimate fate of the universe, We will continue to reach for the stars, driven by the boundless curiosity that defines us as a species. As we finish this journey through the cosmos, we are left with the realization that the universe, in all its complexity and mystery, will continue to inspire and challenge us. And no matter what the end may look like, the search for knowledge will never cease, for it is in the pursuit of the unknown that we find our true purpose.